All right, so here to write in scientific notation, I'm going to count to the right, and I count 1, 2, 3, 4, 5, 6, 7, 8. So I'm moving it 8 to the right, so that's 4.05 times 10 to the minus 8, because I've shifted 8 decimal places to the right. Now here, 3.8 times 10 to the 7th, so I need 3, and then to the right of the decimal, I have 3, 8. 8 counts as 1, and then I have 6 zeros after that, because I need 7 total decimal places when I move to the right. So it's like 1 and then 6 zeros. 3, 4, 5, 6. And so it should look like this, 38 million. Now when I multiply, so remember I multiply the 3 and the 5, and I get 15 times 10 to the 10 plus negative 3. That just becomes 10 to the 7th because I add the exponents. Now this is not scientific notation. So here's my point. I want to move it 1 to the left. So it becomes 1.5. Now to compensate, I have to add 1 here. And it becomes 10 to the 8th. The reason why I am adding is, if you think about it, when I move the decimal 1 to the right, what I'm really doing is I am dividing by 10. And so I then have to keep the value the same, since I'm dividing my value by 10, over here I can multiply by 10, and 7 plus 1 is 8, and that keeps the overall value the same. All right. Now 14, this is probably the most missed one. 2 divided by 8 is just 0.25. And then this is times 10 to the negative 2 minus negative 5. Now remember, that's minus a negative. So that's the same as saying 0.25 times 10 to the negative 2 plus 5, which is 0.25 times 10 to the third power. Now, once again, it's not in scientific notation. I need to, in this case, move it 1 to the right. Just like here, when we move 1 to the left, we were dividing by 10, so we added 1. Now I'm moving 1 to the right. That's the same thing as like multiplying by 10, so I need to divide by 10 here, which is the same as subtracting 1. So let me erase all this. So we're going to just take 1 away. And then my final answer should be 2.5 times 10 squared. The scientific notation. All right. So for 15, 16, there's several different ways you could do this. I'm actually going to show a slightly different way than I've done in class, but I personally think it's the easiest. It takes a little bit longer, but I think it's the easiest to understand. And that's just put them both into non-scientific notation, add them, and then put them back into scientific notation. So this 8.7 times 10 to the negative 6, so I'm going to count 1, and then I would have 5 more, 2, 3, 4, 5, 6. So that should be 1, 2, 3, 4, 5 zeros, and then 8, 7. And then this, I'm only doing 5, so I'm doing 1, 2, 3, 4 zeros, right? It counts 1, 2, 3, 4, 5. So I have 1, 2, 3, 4 zeros, 5, 3. 5, 3 like this. And I'm going to add a 0 here just because it's below the 7. And then I would add these, right? This becomes 7. This becomes 11, and that becomes 6. And then the rest are just 1, 2, 3, 4 zeros like that. 0.00000617. So if you can just put it into non-scientific notation, add them together. And now we just put it back into scientific notation. Now I'm counting 1, 2, 3, 4, 5 to the right. That's 6.17 times 10 to the negative 5th. And that is my answer. Same thing here. Now it's times 10 to the 5th, so these are bigger numbers. So this would be this is 5, so I count 1, 2, 3, 4, 5. So I have 3 and then 4 zeros. So it would be, let me erase this point, 6, 3, 0, 0, 0, 0, right? So 5 decimal places. Minus, now this is 9.3 times 10 to the 4th, so this is going to be like 1 and then 2, 3, 4. So this is 93000. So it'd be 000, and then 3, 9. So it's 9, 3, and 3 zeros like this. And we're subtracting. So this is 2, 10, that becomes 7. This is 5, 12, that becomes 3. So 537, right? And then 0, 0, 0, like that. And so then once again, now I have this, I'm going to just put it back. So I would go 1, 2, 3, 4, 5 here. So that's 5.37 times 10 to the 5th power. Like that. And that's it. I think that's the easiest. It's a little bit longer, but I think that's the easiest way to do it.